Hi Bobcats! In this video we're going to figure out how to write the names and the formulas for binary ionic compounds. Binary means that they consist of two elements, and ionic means that those elements are going to be a metal and a nonmetal. Our objectives are to write the formula of a compound from its name and then to write the name of a compound from its formula. So we're looking to go both ways. The guiding principle behind writing the formula for a compound that's ionic is that we have an equal amount of positive charge and negative charge represented in the formula. So for instance, let's take a look at this possibility. If we want to write the formula for iron 3 oxide, well, iron 3 tells us that we have an iron ion with a +3 charge, and oxide tells us that we have an ion with a -2 charge. So if we take just one of each, we've got 3 positives and 2 negatives, and those do not cancel each other out. So how are we going to do this? Well, if we take just one oxide, we've got that -2. If we take one iron, we've got 3 positives and 2 negatives. If we add those numbers together, +3 - 2, we end up with a +1. So that means we have too much positive charge. So let's take another negative ion, because the oxides come as these lumps of 2 negative charges. Well, now if I add up these numbers, I have 4 negatives and 3 positives. So +3 - 4 gives us a -1. So now I've got too much negative charge, so I need some more positive charge. Aha! So now I have 2 Fe's with +3 charges, which gives us a total of +6. And then I've got 4 negatives, so +6 - 4 means a +2 charge. So now I've got too much positive charge. Let's try to balance that out with another oxide, which gives us more negative. And now, if I add up all my positive charges, I've got +6. If I add up all of my negative charges, I've got -6. So +6 - 6 equals 0. When I have this arrangement of ions, I have a neutral compound. So when I go to write the formula for this compound, I'm going to write Fe2O3. The subscript of 2 on the iron tells me that I have 2 iron ions, and the subscript of 3 on the oxygen says that I have 1, 2, 3 oxide ions. Well, that process of figuring out how to write the formula for a compound seems pretty long and convoluted if we just take one ion at a time until all of the charges are done or canceled out. So there, fortunately, is actually a shorter way to do this. We can take each one of these ions and write them side by side, including their charges. So I can write Fe with a +3 and then O with a -2. If at this point the charges were equal but opposite in sign, I could just clean up my answer and write my formula with just one of each. But in this case, that's not the case. We've got +3 - 2, that adds up to a +1, so it's not a neutral compound as written. So here's what we're going to do, and I should probably change color to illustrate this. I am going to take the number that's associated with the charge on iron, not the sign, just the number, and I'm going to bring it down on oxygen as a subscript. Then I'm going to repeat that process in the other direction. I'm going to take just the number on the oxygen charge and bring that down as a subscript on the iron. When we write the numbers up top to show us the charge, the sign is absolutely required because we have to say whether the charge is positive or negative. But the numbers down below, the subscripts, have a different meaning. They are telling us how many of each element is present in the compound, and so there's no sign associated with that. So when we do this crisscross process, you want to bring down just the number, not the sign, And every once in a while, you will end up with something that is not an empirical formula. As was discussed earlier, you might end up with a subscript of 2 and another subscript of 4. If that's the case, you want to reduce them. But in any case, we want to clean up the formula to give our final answer. We want to lose the charges. We want to lose the crisscross. We just want to write Fe2O3, final answer. So let's work a couple more examples where we're going to write the formulas and the names for the compounds formed in each of these cases. Go ahead and pause the video and see if you can do these on your own. I'll wait. Okay, now that you've started replaying the video, calcium and chlorine. Well, when calcium forms an ion, it's a fixed charge metal, so it's going to form Ca with a +2 charge. Chlorine is a nonmetal, they're all fixed charge. The halogen family is all -1. +2 and -1 don't cancel out, so we're going to have to crisscross. And to clean up, to give our final answer here, we do not write subscripts of 1. So for calcium, we just write Ca, and then for the chlorine, we're going to write Cl2. For our next example, the Roman numeral 3 on indium tells us that the charge on indium is +3. So I'm going to write In with a +3. And then oxygen and all the nonmetals in the chalcogen family are fixed charge with a -2. So I'm going to have to crisscross, bring down a 3 and bring down a 2. And cleaning that all up, I'm going to have In2O3. For the last example, chromium 6 and oxygen, chromium has a +6 charge because of the Roman numeral. Oxygen, being a chalcogen, has a -2. +6 and -2 don't cancel out, so we're going to crisscross. And cleaning that up, we end up with Cr2O6. However, there's a problem with this formula. It's not an empirical formula. The 2 and the 6 can both be reduced by dividing by 2, so we should. And this will reduce to CrO3 for our final answer.